My friends, to another live recording of our math class regarding difficult logarithms and how to re-express them according to a given expression. What given expression, you mean? Well, up here at the top we have log 8 base 3 and log 3 base 2, and the first one is A, the other one is B. And so we're going to use that to re-express these logs. Now we're going to start with number 3. And 3 is a very curious and interesting one because there's an unusual aspect to it that many people do not know. And that is the curious concept of factoring out an exponent. What the heck does that mean? Well, what I mean is if you have a number that can be expressed as a base and exponent, and if both the base and argument share that exponent, then you can simplify that. So it's probably better if I just show you. So, for example, 4 is really 2 squared. And 9 is really 3 squared. And what I'm trying to say is that these exponents will cancel and give you a log of 3 base 2. Now, if you are in any way curious or intellectually curious, you're probably wondering, how is that true? How is that possible? It doesn't seem obvious. And you probably would like an explanation, and so I will give it to you. And so what I will say is that if you express this, let's just rewrite that same expression again. And let's set it equal to x. And then we're going to rewrite the logarithm just as an exponential form. So what I mean is we're just going to get rid of the logarithm bit, and we're just going to say, hey, this is 2 squared to the power of x equals 3 squared. And what you'll see then is that this x here will multiply by the 2. And so this just is the same thing as saying 2 to the 2x equals 3 squared. And then we can square root both sides. Well, square rooting both sides is the same thing as taking an exponent of a half. So if we take an exponent of a half on each of these, I'll just go ahead and do like this. Hopefully that makes sense. Then what happens? Well, this is we have parentheses with an exponent. So this gets distributed to the exponent. And what's going to happen is those 2's are going to simplify away. So we're going to end up with 2 to the x equals 3. And wouldn't you know it, isn't that the same thing as this right here? Which is what my original claim was. And so what I'm saying is that these exponents right here, this 2 and this 2, right, because they're going to be set equal to each other, because we're going to square root both sides, we can get rid of those. And it's another way of saying, hey, we're factoring out that exponent. Now, I've been doing math for a long time, and I really can't remember any other circumstance where this has really come up. But I also have to say, I find it maybe I just found some other workaround that, I didn't need to know this. But I do think this is really cool and could come in handy if you're going to simplify some logarithms. So I think that was really worth mentioning. Unfortunately, I don't have much room here, so I'm going to have to erase this work. So if you want to write this down, please pause and do whatever you have to do. But for me and myself, I'm going to move on. And we're going to move on to number 4, which is just lovely because it doesn't have any of the bases we're looking for. I wish this were faster. But I'm looking at number 4. I do like the 3. So remember our A and B. Oh, I didn't finish the problem. So this right here is just B. In case I wasn't clear. All right, this right here just equals B. Because B, I should have made it blue. Nah, it's too late. It's fine. This is b, just like this one right up here, right? That's log of 3 base 2. Okay, so for number 4, again, a has a base of 3 and b has a base of 2. 6 is none of those. But we could make it 3 if we switch the base in the argument. So we could say that log of 3 base 6 is the same thing as 1 over log of 6 base 3. Now, why in the world would I do that? And
Why?
yeah, exactly, right? So why? Because it seems like you're making it worse. What are you doing? It was so close before. Now we have fractions. Why? Well, if I have the right base, I can make it's just easier for me to see. And that 6, I know is 2 times 3. And log 3 base 3, well, hey, that's just 1. And log 2 base 3, hey, well, that's just some form of b. So I'm thinking pretty optimistically that this is going to work out for us. And that's kind of what I was thinking. Okay, so 1 over, we're going to separate this out, right? So this is log of 3 base 3 plus log of 2 base 3. And let's just make sure we have that fraction bar all the way. And conveniently for us, you can kind of see the rule that I'm going for here in the denominator. Right? I can split up that argument into 2 separate ones. And that's what I want. And the reason why, hopefully you can see, is that this right here is 1. And this right here, I'll make it blue. I wanted to say it's b, but it's actually not b. It's 1 over b. Because b is actually log 3 base 2. Okay, so let's rewrite this nice and neatly so that we can actually make sense of this. So this is 1 over, I'll use the same colors, try to keep that color just for you. 1, although I changed that color, so oh well. 1 plus 1 over b. So how do we simplify this denominator? Well, if we multiply numerator and denominator by b, then that allows us to keep that value. And what we're going to get is we're going to get b on top. And on the bottom, this b is going to distribute to each term. And so we're going to get b plus 1. And I'd say that's pretty good. That's probably as good as we're going to do. So this right here is the answer to number 4.
Wait, I can't see
Oh, you can't see? My apologies.
Wait, respect. Oh, there.
Yeah, or I could just do this.
You
are not rude.
Did that work?
Yep.
Okay. Whatever it takes to get through to the students.
I understand it now.
Thank you. Thank you. I reach these kids.
Too much.
It's from a movie.
Yeah.
Okay. All right. All right, next one. Number 5. Log of a half base 3. Again, I need the room, so I'm sorry. I'm going to erase this. It's lovely, I know, but it's got to go. So, hey, log of a half base 3. Log of a half, eh? Remember that? Remember division in the argument? Remember what we do for that? Do you remember? Subtract. Very good. So this is really log of 1 base 3 minus log of 2 base 3. I think what I encounter the most from students, the difficulty, the resistance, is how did you know to do that? How do I even know that this is going to work out? How do you know that that's the correct move to make? And exactly. My answer to that is I don't. I just know that's a thing I can do, and and that's really why I should probably do it. Because what else am I going to do? I should do the thing that I know, and then probably, hopefully, that's going to work out. I don't always know where it's going. I don't know if it's going to work. I try this, I try that, I try this, and because I've done a million of these, I'm like, yeah, it'll work out. It'll probably work out. Let's try. And sometimes I'm wrong, but like mostly it works out. And that's good advice, I think. I hope. You don't have to know exactly if this is like when you're trying to solve a problem. It's not that you try different tools. Right? You have a problem. You try different approaches, and you're optimistic. You're like, yeah, maybe this will work, but you don't know if it's gonna work. And then sometimes you try it, and you're like, oh, that worked. It's kind of like that. I'm willing to do the work. I'm willing to try lots of different things because I'm just gonna stick with this problem until I solve it. And that's the mentality that I want you to have. Is like you just try different tools until it works. Just don't give up. Just don't get tired. Don't get frustrated. Build up your mental stamina. Solve lots of problems, and you'll get better at it. Yeah. Thank you. All right. Somebody clip that and make me a YouTube video out of that. That'd be nice. All right. Okay. So we are here at log 1 base 3. Log of 1. Hey. That sounds familiar too. What's the log of 1 again? 0. Who said 0? Excellent. 0. That's correct. Log of 1 is just 0. Does it matter what the base is? No. Okay. Some of you guys are looking at me like you don't know what I'm talking about. So let me explain. Log of 1 base 3 means that log 3 to some power equals 1. Well, 3 to what power equals 1? Well, that would have to be 3 to the 0 equals 1. And not only that, but any number to the 0 power equals 1, except for 0. And so, 1, okay, so that means that this is equal to 0. So log of 1 is always equal to 0. And that's nice, because that means it goes away. Right? That means that this is really 0, so I don't care about it. I don't even have to write it. And this right here is just 1 over b. Because b is log of 3 base 2, right? Log of 3b, yeah. Mm-hmm. So this is just 1 over b, so the answer is negative 1 over b. I'll just go ahead and... Whoop. Oh, yeah. Sweet.
You did 1 over b because...
See how you have it selected like that?
I'm sorry?
See how you keep drag and
Yeah.
You can also delete stuff like that.
Okay.
Instead of doing it slowly with the...
Right.
Like select it and release it.
Right. Okay, good. Thank you. More? We have time for more. We're on a roll.
So is 1 minus 1 over b?
It's just minus 1 over b. It was 0 minus 1 over b, but I just...
Oh, it deserves this.
Yeah, I don't care about 0. Yeah. Number 6. Number 6. You guys have tried these, right? If you're watching, by the way, in case it wasn't clear, at this point you pause it and you try it and then you watch my explanation. And don't watch or listen to my whole explanation. Only watch enough to get you unstuck. And then you keep trying until you get stuck again. That's how you can really use this video and learn, get like a live tutor, quote unquote. Right? Like you try as much as you can, and then when you get stuck, you listen. But what the mistake people make is then they like listen to the whole thing, like like only listen enough to get you unstuck, and then maybe see if you can take it the rest of the way. Number 6. All right. To me, this looks a lot like. B. So, once again, sometimes I don't know where I'm going, but I know there's certain things I can re-express. One of those is that the square root of a number is also a exponent of 1/2, right? So if you tell me square root of 3, to me that means 3 to the 1/2 power. And everyone should know that one. So in my mind, this is really log of... do I go ahead and do that already? Don't I have a base 3 up there? That's this. Is there a bit? Oh, yeah. That's A. Oh, my gosh. Log of 8 base 3? Sweet. Oh, this is easy. And so now, this exponent of 1/2 here, remember what happens to exponents of the argument? Those become coefficients. So that's 1/2 times log of 3 base 8. But remember that A is log of 8 base 3. So this is really, this part right here is 1 over A. This part right here, the blue circle, that's 1 over A. Because again, remember, A is log of 8 base 3. They're switched. So the final answer is 1 over 2A. And we have re-expressed it in terms of it.
Why is it 2?
Because there's a half. See that half?
Oh, okay.
It's half times that. And remember where that half came from?
Square. The exponent.
The exponent, yep. More? More. Number 7. Oh, more loveliness. Oh, the joy. Oh, man. It's great. I love it. It's fantastic. All right. It hurts my brain. Stop. Oh, new video? Okay. Yay, welcome. Thank you for watching, everyone. Wow, what a great lesson that was. I'm sure you're inspired. And you are ready to like, share, and subscribe. To share it with your friends and neighbors. People you meet on the street. I saw this video. It changed my life. Buy my merch. Thank you very much.